Hello, welcome to LeetCode Solver. Today we are going to solve 24th problem in May LeetCoding challenge. Actually 24th problem in May LeetCoding challenge, and the problem name is construct binary search tree from Preorder Traversal. Okay, return the root of the binary search tree that matches the given Preorder Traversal. Okay, it looks like we have already solved this problem in not in May LeetCoding challenge, but previous month's LeetCoding challenge. So let's yeah, that is why I already can see the code of this problem. I mean solution of this problem over here, and yeah. So I think the complexity of this solution is big of n log n, and space complexity is big of n. Yeah. So basically, in order to construct a binary search tree from pre-order traversal, what we have to do is we have to first of all we have to figure out the pattern of the input. The input pattern, which is the pre-order traversal, will always have a first element, I mean current node element value, and then after all the elements from the left subtree and all those elements from the right subtree. And we also know that the binary search tree has a uh, property that all the elements in the left subtree will be smaller than the current node, and all the elements to the right subtree will be bigger than the current node. So basically the format of the input will be always be the current node, and there is something over here, there exists a partition, the index, which will partition into a left subtree and right subtree. And the partition is simple, like the partition is occurring will occur from the element which is bigger than the 8. Bigger than 8 is 10, so partition starts from here, which will partition into a right subtree, and all the elements to its left are, I mean, left subtree. So pre-ordered, as the length is 100, we can also do it in, I mean, just iterating and finding the partition. So we can also do this in big O of any square complexity as well. And I mean, as we know the range, like it's a step of our recursive. We will solve this problem recursively, like first finding the current node and giving recursive call, giving its range, and another recursive call to which will return a right subtree, right node, and we will also provide the range. And so range is basically give us the flexibility that uh, the same problem will be solved recursively, and we will provide just the range. Over here you have to find the left subtree, over here you have to find the right subtree. This will range will basically give this flexibility, and we will perform the same thing again and again through recursion. Yes, so as the construct is very small, 100, we can also solve it pre-order distinct. We can also solve it in big of any square. So we are doing binary search in order to find the index where the biggest element uh, occur. So instead of doing that, we can also find the right index just by, say, right index may not exist. I mean, the greater element may not exist in the case where there is only left subtree. So if was no right subtree, then the pre-order traversal will be 8, 5, 1, and 7. So there was no any 10 and 11. So if we do a binary search, then we will not find anything. So we handle this case over here as well if return index is -1. So similarly, we can do a Well, let's begin from let's yeah, similarly we can do it in big like searching linearly. So let's begin from the here, like n is preorder size, and we are passing the range low and high, and preorder is a vector itself. Maybe we have to it would be better to pass it as a reference, and yeah, we are passing it as a reference. And if this is the condition, we are returning null, and current value, we are finding the current value one, and current node is we define the current node with the current value. So if we define in this way, then we will have a value as a given value, and left and right subtree will be null. And if both are same, then we are returning current node. That's good. Otherwise, we have, instead of doing binary search, we can also, let's define right index as a -1, and instead of binary search will give us log n complexity, log of range complexity actually, and we can iterate from of the given range low. Actually, we don't need to iterate over low, high, and we will go over the range, current range, and if we see that pre-order of I is greater than current value, if it is greater, then we will find the right index will be equal to I, then we will break. If nothing satisfies this condition, greater condition, then we will have -1. So if we do not have -1, then it is better we will just give a same recursive call and pass the right index for the right node, and high, the range will be this, and for the left node the range will be low +1 to right index -1. Sounds good. And otherwise, if there is -1, then we cannot form any right subtree. So definitely right subtree by default is null, initialized as a null when we define this tree node, current node. So current node, we have to define left node only. That left will be current nodes left will be low +1, high preorder. Yep, and we will return current node. Let's run the code, and I think this will also pass the big O initial solution will also be accepted, I guess, because the range is very constraint is very small. Yes, it is accepted. And thank you so much for watching this video. I'll also include the link of my previous uh, video where I explained this binary search solution, and today I just replaced that binary search with the just a linear search iteration. And here complexity we achieved is big O of n square. Yes. Yeah, if you have any question or any comment or any better approach, please feel free to share. See you in the next video.